Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video we are going to look at the implementation of tensors. So how to create tensor, basic math operations, and look at the shape and rank of some of these tensors. So let's get into let's get into Colab now. We'll be using this online notebook, this particular series. So the very first thing we'll do is import libraries. So libraries, and we need numpy, so we'll import numpy as np, and we need tensorflow, so import tensorflow as tf. And as you'll see in this particular notebook, we haven't selected gpu runtime. So if you click on change runtime type, here you'll see that it's none, and we have not selected gpu or tpu, and that's because we do not need it for this exercise. A difference from Jupyter Notebook is that after the cell is run, on the left hand side we also get how many seconds it took to run the cells, and after the cell is run we get this number for the cell in square brackets. So that's nice to. The very first thing we'll do is we'll look at a rank 0 tensor. So rank, if you remember from the previous video, where we looked at different ranks of the tensor. A rank 0 tensor is simply a number. So rank underscore 0 underscore tensor is equal to tf.constant, and if we specify digit 2 there, we can get the rank 0 tensor as we'll see now. So points to note here are that the shape of the tensor, as you can see, it's empty, and that's because there are no axes to this particular value of 2, and so the rank is 0. And we get a data type which is integer 32, and we have the value which is 2. If we change this to 2.0, then the data type should change, and here we get float 32. Now, as compared to NumPy, you are familiar with NumPy. You know that to create an array, we use a command like np.array. So let's create a NumPy array, and let's say if x is a NumPy array, and we have 1, 2, and 3, then x we get this particular value. So NumPy array 1, 2, and 3, and that's really interesting because in TensorFlow we can achieve the same uh, creation of a tensor by replacing this NumPy array with tf.constant. So let's now create a rank 1 tensor, and a rank 1 tensor, and as if imagine this would be just one one vector as we have above. So tf.constant, and here we can specify within square brackets 1 comma 2 comma 3, and this would be the rank 1 tensor. So if we if we run this cell, here we can see that this particular tensor has one axis, and so the rank is 1. The data type is integer 32, and the values are this particular array 1, 2, 3. Now here again, if we change the data type to 1.0 and then run this, then we see that the data type for this entire tensor becomes a float value, and the size in this case of the tensor would be 3, because there are 3 elements within this particular tensor. Next, let's look at a rank 2 tensor. So rank 2 tensor, and again here we can type tf.constant, and because this is a 2 tensor we need 2 square brackets there. So here we'll specify 1, 2, and 3. That's the first row, and then we would also have a second row, 4, 5, and 6. And now if we run this, here we should see a two-dimensional array or a 2D tensor which has 2 rows and 3 columns, and the shape is therefore 2 comma 3. The data type again is integer 32 as we would expect, and as before, if we change the value to a float, then the entire tensor becomes a data type float 32, as we can see. Moving on now, let's look at a rank 3 tensor, and as you've guessed by now, it would be similar to this, except that we'll have 2D matrices stacked on top of each other. So let's put some space there and add that here. So this is one matrix, and we need to enclose all of this into a square bracket. So what we can do now is copy this, and we can add two matrices right here. This is 1, and then add another matrix here which is 2. And within these we need to put a comma there so that it knows that there is another matrix below it. So let's change these values a little bit, maybe add 1 of these. And now when we run this particular cell, here we see that this is a rank 3 tensor. So this was rank 2 tensor. Now we have rank 3 tensor, and points to note here is that the shape now has 3 values in it. 3 because there are uh, three um, matrices, 3 two-dimensional matrices stacked on top of each other, and then the dimension of each of those matrix is 2 by 3. So 2 rows and 3 columns. Float 32 is the data type because we have some values that are float, and here we see the printout for output for the 3D tensor stored in variable x right here. Apart from that, now if you are wondering, is there a way to convert a TensorFlow tensor into a NumPy array? And that is possible. So let's see how we can do that. Before we do that, we need to add a cell here that is markup, markdown cell, and what to add that we can click on this text, first text, then as we would do in Jupyter Notebook, here we would type convert a tensor to np.array or to numpy array, and that's the heading we have. So for this, let's use the tensor that we had created earlier, which was the rank 2 tensor, and put it here. So to convert this to an array, we can simply type x is equal to np.array. This is x. That should, let's convert this. So let's call this rank underscore 2 underscore tensor. So we know that it's different. Now when we run this, we should get output where the variable x now stores an array. So this is the array that is a NumPy array. There is another option to achieve the same output, which is by using .numpy. So if we type x is equal to rank underscore 2 underscore tensor, and if you type .numpy in front of it, tensor.numpy, and you run this cell, here we should get the same output as before, where we have NumPy array as output. Now let's look at some basic math operations that we can do with a tensor, and put a heading basic math operations. And as you'll notice, the operations are pretty similar to what we have seen with NumPy. For this, we'll create two new tensors, two-dimensional tensors, tf.constant, and the first one is has a row with values 1 and 2, and the second row has values 3 and 4. Similar to this, copy this, paste it down below, and sorry about that. We'll add uh, new values, and let's change this to variable y. Let's make these 10, 20, 30, and 40. So these are the two tensors we have. The very first operation we'll try is add. Add underscore xy is equal to tf.add x comma y. And if we look at the value of x underscore y, we should get the element wise addition of this. So 1 plus 10 is 11, 3 plus 30 is 33, and so on. Next, let's look at, after this, let's look at subtract. So subtract, and for this subtract xy equal to tf.subtract x comma y, and we look at the output of this x comma y. We get 1 minus 10 is 9, and then 4 minus 40 is minus, sorry, 1 minus 10 is minus 9, 4 minus 40 is minus 36, and those are the values we get. Again, the output value is also a tensor, and we do have the shape of the tensor that was same as the input values. Next, let's look at multiply. So for multiply, uh, it's going to be the same line of code. So I'm going to copy this as is and simply type multiply here, copy and paste that in here and over here. So the multiplied values are its element wise multiplication. So 1 multiplied by 2 is 10, that's what we have here. Then 2 multiplied by 20, that's 40, that's what we have here, and so on. And if for any time you are looking to find what a particular operation does, if you are not sure about it, we can always look at the help menu. So for now, let's say we have matmul, and if I copy this and paste it here. Now if I want to look at the help menu for this one, what I can do is type tf.matmul question mark, and on the right hand side then we get this output, the help menu. Here we can see the description. It multiplies matrix A by matrix B, producing these values. The inputs must follow any transpositions, the rank greater than equal to 2, etc. And these are, so we have all the details that are given here. And again, here we can have additional arguments that we can pass to to this particular command. So I'm going to close that for now. And again, when we run this, we get the values for this operation, which is shown right here. Now moving on, let's try another one, which is divide. So divide underscore xy is equal to tf.divide x comma y, and divide xy, and here we get the division values. Now apart from using these words as divide, we can also use symbols to perform the same operation. So let's start with addition. So let's say we want to do x plus y, we would simply type x plus y. And now if we want to try subtraction, we can type x minus y. So we get the subtracted values. And this works similar to what we have been using in Numpy. x divided by y. So we have these values, and we can also do floor division. So x double backslash y, and here we see that these are the values. Additionally, there is another non-intuitive way to perform multiplication, which is using ampersand. So x ampersand, sorry, x, uh, uh, yep, with this a, and then if you run this, we get the matmul value for the output tensor. Now, apart from the addition, subtraction, there are other operations that can be done, which is finding the min, max for a particular tensor. And these are very useful, basic but very useful operations that we'll be using quite often. So operations such as min, max, etc. Let's look at few of these now. For this, I'm going to create another tensor, constant, and let's have some values for this. So let's say 100, 2.0, 3.0, make this 100.0, and then a second row that has value 4.0, 5.0, and let's say 600.0. So these are the values we have. We look at the x in the output, and we should see that it's a two-dimensional tensor with shape of 2 by 3, and the data type should be float. So with this, then that's what we have as values right here. Now, if we want to find the max value, how do we get the max value? So max value for the entire tensor. So to do that, we can get x. So x max, and this is for the entire tensor. What we need to type is tf.reduce underscore max, and here we can specify within parentheses x. So x underscore max underscore all, that gives us the maximum value, and the value is 600, and we have that value right here. And because the output value is a one, it's a zero rank tensor, here we do not have any values for the shape because it's just a number float. Apart from the max all, now let's look at the numpy alternative of this. So we would simply type np.max x, and this should give us the value for the maximum value for that array, and we can directly input the tensor into numpy to get the maximum value. So that's also doable here. Now let's look at if we were to get the maximum value by axis. So this is by axis, and for this we can specify, we can input an argument axis is equal to 0 or 1. So if we need to find the max for each of the columns, we can type tf.reduce max, and here we can specify our tensor x and then specify the axis as 0. Now if we look at the max value for the column, we should get 100, 5 and 600. So that's what we have here. Similar to this, we can also get the max value for each of the rows that are there, and to get the max value for rows, we simply need to change this to 1, and we can rename this variable to call it row, and when we run this, we get an output which is 600 and 600. So the max value in the top row is 100, max value in the second row is 600. So that's how we can get the um, maximum values. Now, apart from the maximum values for rows and columns, we can also get the minimum values, and the minimum values would be similar to that. So we can look at just one example for min. So if we get the min value by axis, so let's copy the string here and paste it here. So for min value, again, if we look at by columns, we can see that we get three values. 4 is the minimum value here, 2 is the minimum value in the second column, and 3 is the minimum value in the third column, and that's what we get here in the output. Apart from these min max values, we can also get the index associated with the min and max value for the tensor. So let's see how we can find those values. So if we want to get the index, get index for the largest value. To get the index for the largest value, then what we need to do is use tf.argmax. So if we create a variable x argmax is equal to tf.argmax. Here we can specify the tensor, which is x, and we can specify the axis is equal to 0. And if we look at argmax now, here we should get, so here we see that the values are 0, 1, 1. So the value is 0 here, so 0, uh, 0th row, we have the max value when we are looking at axis 0. The second column, the max value is at index 1. And again in the third column, we have the max value at index 1. So that's the way we can get the max value by axis. And I'm just curious to see what we get when we keep the max. If we do not specify the axis here. So if we just put x instead of any axis, and if you run this, in this case, then the max value that we have in the tensor is 600. And again, default, we get the values for each column. There's a index for each column. So that's what we see. And as before, we can always look at the help. So if you click on this and if you type tf.argmax and look at question mark, it opens up the help menu on the right hand side of the notebook, and we can look right here. So returns the index with the largest value across axes of a tensor. In case of identity, returns the smallest index. So it returns the index value along either of the axes. And if axis is not specified, let's try putting the tf.axis as none. So axis is equal to none. So that's the default value, and we get the same output. In addition to this, we can also get the value for softmax. For now, if you do not understand what softmax is, that's perfectly fine. We'll be covering that in much detail as we go through this series, not this video. Sum of all outputs of a softmax equals 1. So you 1 there. Okay. So now here, let's get the softmax value of x. SOF softmax is equal to tf.nn.softmax of x. And when we get the values for this x softmax, here we see that this is the output. And if we were to add these values up, so because these values are way off, that output is not very interesting. So let's try to change that and bring these values down. So let's say this is 1 and this is 2.5, and run this again. And now you'll see that these are the values, and if we add these values uh, across these rows, then we should get 1. So if I run here, And if we take the sum of this, so we just now learned how to get sum across axis. So reduce underscore sum and x underscore softmax, put axis is equal to 1, and we'll look at the output. And as you can see, the value is 1 for this top row, and the value is almost 1 for the second row as well. So that's how we can get softmax matrix. And in Keras, usually when we build sequential models, this would be the last layer uh, in the neural network. Moving on now, let's look at uh, rank of a matrix. Again, let's create a text cell and add a heading, shape, and rank of a tensor. And the first one we'll look at is rank 4. So we'll create a rank 4 tensor. So rank 4 tensor, and to do that, rank underscore 4 underscore tensor. That's the variable we created. We'll create the zeros. If 0, all values will set it to 0. And because this is a rank 4 tensor, what we are going to do is we are going to have a stack of these matrices which also have depth. So let's say we have a 4 by 5 tensor, and each a 4 by 5 matrix. So let's run this. We have a 4 by 5 matrix. TensorFlow has no, oh sorry, that should be a 0 with a S. So 4 by 5 matrix, so that's 4 rows and 5 columns. Now if we add, this becomes a large matrix. So why don't we reduce this size so we can easily read this. So for 2 by 3, and as you can see, there are two rows and 3 columns. Now if I were to add depth to this particular matrix, let's say if it were an image and it had RGB channels, we had a depth of 3. So now to make it more readable, let's add 4. Maybe it also has an alpha channel, so 4 values there. So this should be 4 here and there. Okay, so now what we have is a stack. We have a 2 by 3 matrix with 4 stacks around it. So imagine image image matrix that has dimensions of 2 by 3, and each and it has 4 channels, so they are stacked back to back, and so that's what we have. Now if we have let's say 10 such images, or let's say if we have maybe 5 such images, then we add another dimension there, and now our matrix becomes like this. So what we have here is this is the first image that has a size of 2 by 3 with 4 layers stacked side by side, and so that's 1, this is 2, this is 3, so 5, this should be 0, 1, 2, 3, then 4 and 5. So that's how this works. So let's copy this, or maybe I'll just type it here. 5 comma 4 comma 2 comma 3. So that's our rank 4 tensor, rank 4 because there are 4 axes in there. And now we can look at the data type. So to find the data type, we can say rank underscore 4 underscore tensor dot d type, and copy this because we'll be using this for d type. And here we can see that it's float value. It's a float value. And next, let's look at the number of axes. So number of axes, and that would be again the variable this with ndim, and we have 4 axes, and that's what we have, and therefore it's a rank 4 tensor. Next, let's look at the shape of tensor, and this would be dot shape. And here we see that this is the shape. It's going to be the same because that's what we specified while creating the tensor up above. So we have 5, the shape is 5 by 4 by 2 by 3. Now if we were interested in finding how many number of elements are there in along a particular axis, we can find that. So let's say find number of elements along an. So to do that, what we would type is type the variable name, then look at the shape 0. So here uh, the number of elements along the axis 0 would be 5 because we have those 5 blocks of 2 by 3 by 4 matrices or tensors stacked, and so that's why we have a value of 5 here. Similar to this, we can also get the value for the last axis in the tensor. So to do that, we can simply type tensor dot shape and specify -1 as the index, and here we have the value as 3, which is shown here. Apart from this, we can also get the total number of elements in a matrix. So let's find out how. So total number of elements in a tensor, I'm calling it matrix or tensor, tf.size, and if we specify the name of the tensor, here in this case we have a total of 132, and that's because 5 multiplied by 4 multiplied by 2 multiplied by 3, and that is equal to 120. So that was it then for this video. I hope in this video you learned how to create a tensor, how to create tensors with different dimensions, different ranks, how to uh, find the shape of a tensor, and then how to perform basic operations such as addition, subtraction, etc. for each of these tensors with different ranks, and finally find out how many elements are along each of a specific axis of a given tensor. In next video, we'll continue our coding sequence for tensors and look at indexing and some other operations. If you have any comments or suggestions, please let me know in the comment section below. Until then, thank you.